All right, we'll try it. So thanks, everyone, for coming. I'm Dominic Williams, founder, chief scientist of the Definity Foundation. We're the largest contributor to the Internet Computer. And my talk today is next level Ethereum using the Internet Computer. I'm going to talk about how these two networks are synergistic. So for those of you, how many of you know about the Internet Computer? Can you raise a hand? Okay, so it's actually pretty good, yeah. It's a blockchain that behaves a bit like a cloud, a smart contract cloud, and it enables you to build anything fully on-chain. It has trustless multi-chain functionality, which means you can build dApps across multiple chains. The network is actually a DAO. So there's this thing called the network nervous system that's integrated into the ICP protocols. And the network is configured and updated in an entirely decentralized and automatic way. And lastly, the entire network runs on sovereign hardware. So there are no cloud validators on big tech. It's all these things called node machines. Definity Foundation is kind of designed as a NASA for decentralization, and it's created the Internet Computer with more than 1,000 person years of R&D effort so far and counting. And the mission is to enable what we call blockchain singularity, which is essentially the migration of all compute on-chain. So we see blockchain as the future stack and replacing current IT. We're an early spin-out from the Ethereum community, probably dating back to 2015, about 300 people globally, and we're headquartered in Zurich. So the paradigm has been pretty successful. We've seen 300% growth in compute year on year. And today, the network's processing 350,000 plus Ethereum equivalent transactions a second when you're actually measuring the low-level virtual machine instructions being executed. So I invite you to go to the dashboard and have a look at this thing. It's currently processing more smart contract compute than every other blockchain in existence, multiplied by some crazy factor. So you might be wondering, what are the trade-offs? Of course, there are some smart contracts on the Internet Computer work differently to smart contracts on Ethereum. On Ethereum, smart contracts are synchronous, which makes DeFi simpler. On the Internet Computer, smart contracts are asynchronous, which means they can run in parallel, and that enables horizontal scaling, which is, of course, part of the purpose of the Internet Computer. When you code Internet Computer smart contracts, they can look synchronous, but in fact, the function calls to other smart contracts and the results are being passed as messages. On Ethereum, the user always pays for the gas, right? So you'll create the transaction in something like MetaMask, and you'll configure the amount of gas you're going to pay for the smart contract computation that will result. On the Internet Computer, the smart contract always pays for its own computation. So you charge the smart contracts up with gas, it's called cycles on the Internet Computer, and they pay for their own computation. And this is really important. It's called reverse gas. And it's really important because it enables the smart contracts to stay in the background and do things like directly interact with users by creating interactive web experiences by processing HTTP. Ethereum, of course, is expensive, costs a few dollars per transaction. Internet Computer, very inexpensive. So you can imagine taking the Ethereum cost and dividing it by something pretty big, like 1.5 million times. Very different things. So when you integrate ETH and ICP, you really can build anything fully on-chain. So the Internet Computer, of course, hosts these things called Canister smart contracts, which can store and process massive amounts of data, and they can create interactive web experiences. But the Internet Computer Network also has this thing called chain key crypto. And actually it's integrated with both Ethereum and Bitcoin at the network level. And this chain key crypto layer enables smart contracts on the internet computer to create signed transactions that run on other blockchains. And this allows for trustless integration without bridges. So already today, for example, people are using what we call chain key USDC, which is really just USDC on Ethereum on the internet computer. And we're sort of almost to the point where you can do bidirectional smart contract calls, which will be a big game changer. And with this kind of functionality, we're entering a new era of full stack decentralization, where things are built 100% on chain without current IT. So today, there are already things like social networks running 100% on the internet computer without any need for things like Amazon Web Services. Also things like order book dexes that look like CFI but are actually running 100% on chain. And the latest thing is we've now got neural networks running as smart contracts. So you've got AI smart contracts. So we'll talk about a bit about AI. And AI is going to be the beating heart of Web3. It's incredibly important for Web3, and I invite you to dream a little, and we'll go through some examples. So the first example I'll give you is smart contract safety. Today, you can go to Etherscan, and you can check out the Solidity code behind an Ethereum smart contract. The problem is, of course, that most people don't have the skills to audit Solidity code. So they've got no way of knowing whether the smart contract is safe. Now, does it have reentrancy bugs? Does it have a backdoor that could lead to a rug pull? Does it contain malware that will cause it to attack other contracts? Most people just don't have the skills to audit it themselves, and even if they have the skills, they haven't got the time. So the solution, of course, is to use an AI smart contract. It'd have to be something akin to an LLM. And this AI smart contract can enumerate the Ethereum blockchain, look at the code hashes, download the code from GitHub, and essentially verify that there's no reentrancy bugs, no backdoors, no malware inside, and create a certification that can then be displayed on something like Etherscan. So you can say, yeah, this Solidity code has been verified by AI. And of course, this is only really meaningful if the AI is running as a smart contract. Otherwise, who knows what logic it's running, right? Autonomous KYC. So something interesting coming is that people are going to want to trade security tokens on DEXs. And we're based in Switzerland, and regulatory changes there have meant that you can tokenize the stock of a company. And that's going to work fine, but of course there are still regulatory restrictions, and KYC and AML and things like that are part of them. So you got a DGen, he wants to trade security tokens on a DEX. What do? Well, we want to make everything as decentralized as possible. So you can use an AI smart contract to do facial recognition and match a person on a video feed to identity documents. And you need something else that can validate the identity documents, but there are lots of people who've done that. And then the AI smart contract can issue credentials to an identity system and allow that user to trade the security tokens on a DEX. So this actually is an interesting example because we've just been playing around with smart contracts on the internet computer that do facial recognition. And if you follow me on Twitter, you'll catch them. I think within a couple of weeks, I'll post that video. There's already a couple out there. So that's AI. What about multi-chain? So there's a wallet under construction called oisy.com, which I think helps explain this in a really simple way. Is this thing a website or is it a wallet? The answer is it's both. It's actually, of course, a smart contract that's creating the interactive web experience. And the smart contract holds the crypto. It's a multi-chain wallet that holds the crypto using chain key technology. And the user authenticates to this smart contract using a passkey-based system, which is much more secure than having a seed phrase and things like that on your system. And it's seamless. Once you've authenticated, you can do stuff. You have a single list of assets. Currently, it's got Ethereum assets and Internet Computer assets in the same list. Bitcoin will be added soon. And it's fully compatible with Ethereum DeFi. So you get this added security, censorship resistance, right? Because nobody can block a smart contract that's serving web, but Google can chuck wallets out of the Chrome store. Apple can ban wallet apps from the App Store. You get rid of that. So you get censorship resistance, you get more security, and you get user experience benefits. And all of this is working without bridges. It's all based on trustless math and direct network integration. So Internet Computer nodes talk to Bitcoin nodes, and they talk to Ethereum nodes. So some of you might be sort of making the jump and thinking, like, when LLMs inside smart contracts, right? Because once we have large language models inside smart contracts, we can do all kinds of really sort of sexy and fun things with DeFi. So you can imagine saying to your wallet, like, cancel all my previous instructions, sell half my wrap BTC for USDC if the price hits $100,000, swap half my USDC for the ETH whenever the price falls 10%. Every day at midnight, swap 10,000 USDC for ICP. And you could give that kind of instruction to your wallet over your phone from the beach. So that's what's coming. And that's one of the reasons we are working very hard at Definity to enable the Internet Computer to run LLMs, and it's not so far off. Social media, there's actually this really mature application called OpenChat. You can find it at oc.app. It's worth checking out. It's a sort of mix between social networking and messaging. And it's 100% decentralized and fully on-chain. Smart contracts, process and store profiles, messages, media. And every user's account is also a wallet which can hold tokens, which shows you that a wallet can be anything, right? A wallet can be an application. It doesn't have to be a wallet. And users can do things like send chain key Bitcoin in about 1 second inside of chat messages. And I think this illustrates some of the advantages of being fully on-chain and not depending on users having to configure every transaction themselves and allowing transactions to happen in the background within a secure session, which is only possible when you have things fully on-chain and users are interacting directly with a smart contract. So they create a session with the smart contract knows they're interacting with their user, and the smart contract does things on their behalf. And this thing already has many tens of thousands of users because it's able to scale horizontally. And this is one of those kind of like counterintuitive things. We see blockchain as a scaling platform. And I think the proof's in the pudding, and you can see it working with this OpenChat service. And what's incredible is, like, you've got this social media service with tens of thousands of users inside who are using the service to store crypto. Like, their accounts contain crypto, right? But it's a small team of engineers. There's no security team. They do some code audits, of course, but it's pretty safe. There's no firewall. There's no anti-intrusion software. There's no anti-malware. And that's because it's fully on-chain. There's no hot wallet running on Amazon or something stupid like that. The whole thing's on-chain and end-to-end. And furthermore, this service, OpenChat, runs under the control of something called a Service Nervous System DAO. And that gives the community of OpenChat full and exclusive control of the service. So all of the software updates actually propose to this DAO. And if they're accepted, they're pushed into the service, the smart contracts that make the service, with complete automation. So keep going, see what happens. Games. So actually, I don't know, for those of you who know me for a while, I mean, before I pivoted full-time into crypto in 2013, I had a game, a computer game, it grew to about 3 million users. And so I kind of felt like, recently that, we need to see some fully on-chain games and create a game that really illustrates to people the advantages of being fully on-chain. So I got involved with this thing, and it's called Royale. And so basically it's like survive to win, okay? And because it's fully on-chain, again, tokenization is seamless. And your life is Satoshi's way, or E8's, which is the internet computer equivalent. So there's like Bitcoin Royale, Ether Royale, and ICP Royale. And what's cool here is that the smart contract is the game server, right? And so it's creating a kind of environment that's a sort of mix between first-person shooter, RPG, and real-time chess. You can make one move every sort of second or so. And the idea is, you kill other players, get their life, i.e. Satoshi's way or E8's, and then when you get down to the last 10% of players, it's game over, and you get to keep what you've got in expectation, 10x what you started with. You can only do something like this if you're fully on-chain. In the same way, you can only create something like OpenChat, where you can send crypto with chat messages if you're fully on-chain. You have to put the user within the chain environment. There can't be an intermediary. So, invite you guys to join us and, look at ways that you can integrate with the internet computer. There's very exciting things are possible when you combine Ethereum and the internet computer. There's ICP hubs all over the world now. There will probably be more than 40 by the end of this year. And I don't know how long that went. Have we got time for a quick question? Or quick question. All right. Questions? Anyone? You have to shout it out.
Yeah, regarding the AI application, are there any limitations now for the type of models? For example, if it's a computational neural network that needs GPU, is it really possible to run it like an on-chain ML model?
Yeah. So there are two kinds of tasks, right?
Convolutional, I mean.
Yeah, with an AI model, there's training and then there's inference. So training is much more expensive. And
yeah, just running a model that is already learned.
Yeah, so training, you're going to need GPUs and you probably do it off-chain, but inference works just fine on-chain. So, I mean, there are a bunch of things that the internet computer does which are unusual. For example, it can run transactions across multiple blocks and so on and so forth, and it's extremely efficient. But yeah, inference works just fine. We haven't done large language model inference yet, but we're trying to get there. The challenge there is that, currently the internet computer uses 32-bit WASM, and so you basically need twice the smart contract memory as the number of parameters. So the neural networks that we've demonstrated so far have like 2 billion parameters or less, so they fit in the 4 gig that 32-bit gives you. But the internet computer is moving to 64-bit WASM soon, and then probably the memory limit will be raised to like 15 gig, and then you can fit like Llama in. So we'll have to see how fast that runs once we get there. But so far the signs are very encouraging. Since I did my first demo, April or something, March, I lose track, but we've increased, sped things up enormously. For example, we've had SIMD instructions, which allow the WASM to process multiple calculations in parallel and things like that. But so we have, we're trying to get to adding GPUs to node machines. It's on the roadmap. You have to create once there's a public spec, like node providers can build these machines. They'll be expensive, probably like 120 grand each because the cost of H100s and things. The challenge actually is the determinism of GPUs. And these GPUs have a lot of cores, and the order of calculations that you upload to a GPU isn't deterministic. So we're putting a lot of effort into finding ways to make it deterministic, and actually there are other reasons to make it deterministic too, not just for AI, speeding up AI smart contracts. Fully homomorphic encryption can actually be made practical using GPUs, but same challenge, it needs to be deterministic. So that's something we're working on. But
Yeah,
you know,
to
I
make
think,
like deterministic state transition as usual. Yeah, I mean in blockchain, yeah, we cannot make anything if it's not deterministic. So yeah, we need first.
it has to be deterministic.
Yeah.
It absolutely has to be deterministic. Yeah.
And regarding the privacy of this data that is processed and both the parameters of the model, is it somehow possible if it computed on chain but still make it encrypted, maybe private?
So internet computers, works in a very different way, and you can see that from the performance metrics you get out of it. So with the number of transactions it processes, you couldn't have a blockchain where everyone validates it by downloading it to a local client. So it has a single, it's also chain key crypto. So you have inside the network, you have these transparent subnets, which are blockchains. They all have their own public key. Obviously, there's no private key because that wouldn't be secure. And that's how replication is limited. It's a thing called deterministic decentralization. So the network nervous system that runs the network creates these subnets by drawing nodes from different node providers, different data centers in different geographies, data centers in different jurisdictions. And that's how it really brings the replication factor down while preserving security and resilience properties you expect with a blockchain. So, I think at the moment the demos are running on 13x replication. So I don't know how much you know about it. It's 3f plus 1 and f is 4 in this case, right?
Thank you very much.
But the thing is you can't connect to those subnets and just download all the blocks. I mean, blocks aren't even stored anyways for that long. So to actually get the data, you need to get physical access to one of those node machines. So yeah, the node providers in principle have it, but that's not obviously their interest. Right?
Thank you so much, Dominic. It's our time.
Thanks very much, everyone. Thank you.